Okay. Hello. You can hear me? Okay. So before we get started, I want to highlight several things, and just to avoid any unnecessary, freak out or last-minute freak out when you submit your files in the lab sessions. So that's actually did happen in last 2 times or 4 times. So if you construct your report definitely need to have some words, not just a graph. So that doesn't work. And one case is you cannot repeat just one word for 20 times. So Turnitin will still reject it. So it's a very smart system. And also you cannot have any very special characters, very special things on your file name, like those things. And you cannot have more than 1 dot. So this is the only dot you can have in your file name is .pdf or .doc. So you couldn't have any other docs like a file .na.me.cao. No, that won't work. So the Turnitin system will reject it. So it's not possible to submit anything. So and this is something you have to remember. Otherwise, maybe when you submit something, so always got rejected. That's very frustrated and gives you the last minute freak out. That's really not very nice. Okay, and so you should have your exam name in your file name, and your file name should not be very, very long, longer than 40 characters that will be rejected. So this is several items I need to highlight. Okay, so yeah, that's something I want to say next time. Okay, as promised, so we're going to have a discussion in detail about tomorrow's and the last time computer lab assessment. So this is the question. Actually, you're going to have the question tomorrow. You don't have to take any pictures or whatever, so because this video has been recorded, so you could watch that. So how many times do you like? So as many times as you like later on after the lecture. Okay, so we're going to have this project management lab assessment next time. So this is about design a spreadsheet to solve all the activities and try to find out optimal solutions. And this is about a manufacturing line. We have like a bottling line. So we need to, it's a little bit confusing because we need to closing a line and open a new line, and we're gonna basically installing new line equipments, and we have to remove the old equipments from the old line to the new line and fix into the new line systems and to try to make everything work. So there's a lot of activities in here. So when you do this job, you have to read very carefully about every line. So there are several different activities, and every activity needs different times and needs different number of staffs. Okay. So this is all a bunch of descriptions. So in here, so you will have to answer several questions in here. So this is basically a general description of the whole question. So what I want to do is give you a slightly better document in here. So this is basically analyze the document. So I highlighted every activity. So this is the highlighted activity with IDs in here. So I give you an ID. You don't have to follow that. You could have your own ID. It really doesn't matter, but this is just a reference. So the resources we need is in red. And so the time we need is actually underlined. So we have a bunch of different activities. So I give it an ID to new equipment ordered. So order new equipment as B, and shut down or close the old manufacturing line as A. And we have also removed the old equipment as C, set up the BAIS as D, and installing new equipment and installing old equipment. So we need to closing down the old equipment and remove that to a new place and installing a new line. And also we need a training staff and raw material to be transferred to the new place, and have some trial runnings and full production runnings. Okay, so this is all the activities. So what you have to do is, and this is the question you have to solve, 5 questions. This is actually 4, I think, because the first one and the second one is basically the same thing. You have to break down all the activities and have a very clear structure of this is the activities and this is the dependencies. So this is the resources we need and times we need. So this is basically what we need to do in the first 2 questions. And so what you have to have at the end in your report is something like this. This is, for example, you don't have to have exactly the same descriptions in here. So order, outline, removement. So you could basically have your own words in here. Remove the outline or remove the old manufacturing line. Installing a new line. So this is several categories of activities. So we have closing down the line, remove the old equipments, and installing the new lines. We need to buy something, buy a new equipment, and prepare the base. Installing the new equipment and installing the old equipment, which is removed from the old manufacturing line. We need to train the staff after installing everything, and also we need to prepare for the production. So trial runs and food production and transfer the materials. Okay, and in the descriptions, we basically have a number of some descriptions of the dependencies. So for example, like shutdown and required, so this is the requirements. When a line is shut down, the old equipment can be removed. So that means we have to shut down and then remove. So this is the dependencies. And also when the new equipment has been delivered and BAIS is ready, so it's possible to install the new equipment. So that means we cannot start installing new equipment before we have the new equipment delivered and the base is ready. Something like this. So read carefully about all the dependencies. So, and finally, we should have a table like this. So this is the table we should have. We should have a very clear list of all the activities and the dependencies and durations of resources. So this is basically copied from the documents. You have to be very clear. So what is duration, what is resources we need. And this is all the activities. And the final one, basically, that's a virtual one. So this is the food production. That's just an icon here and just showing we finish everything. And also, we need to have some dependencies for the last step. And if we don't have any dependency, apparently, that means we could start immediately at the first step to start to closing down and start to order some new equipment and start to prepare the base. Okay, so this is the first thing we need to finish. This is actually the answer for the first one, and also the second one. Okay, so once you have this, so basically we should be very clear about this, but this is not requirements in your report. You don't have to draw this. No, you don't have to have this in your report. But this is, you should be understand how to analyze this. This is basically based on the dependencies in here. If we know those activities, and we should be very clear to know how to calculate the early start, early finish. And once we finish all the early start, early finish, it's quite easy to going back from the last step to the first one, going from the right-hand side to the left, and to calculate the late start, late finish. This is only for your reference, because the early start will be, the information of early start will be required for our calculation in the next steps. But you don't have to draw this, so you should be very clear. So this is our free flow, and basically you have some space to move certain activities. And once you have this, basically you could be very clear about this, but this is the slack and the free flow. But you don't have to have this table. This is not required for your document, for your report. And the next one is basically, this is what I draw, so by using Excel. So this, apparently we have several resources conflict in here, so we need 8, 6, or 6. This is something we need to solve later on. But this is also not required. Okay, so once we have this, and we should be very clear about how to calculating all of those tables and early start times in here. So, and then we should think about and solve the problem using Excel. So this is actually, we have very similar or almost the same examples in in the lecture. But what I want to do is show you briefly how to do this. So apparently this is quite similar to the templates you could download from the lecture slides, lecture materials. And we can try to formulate everything in this table. We have a number of activities from 1 to j, and we know the durations. This is the information, basic one we have. Starting time, we don't know. We like the Excel to determine everything for us. And this is only for our references. So this is not required for this first step. So this is early start from, if starting from 1 and day 1, or because in Excel, because for simplicity, we started from day 0. So that's pretty easy, because if we're starting from day 0, for activity 1, so we could, starting from day 0, duration is 1. So basically, the next step should be starting from 0 plus 1, so day 1. So we finish activity day in just 1 day, day 0. So that's pretty easy. So we could just simply plus, and we don't need to minus 1. We don't need to do the additional calculations. This is for simplicity. So in Excel, we're starting from day 0. And this is the references. So if we're starting from day 0, so this is the early start time. Okay. And apparently, if we have this, so we could pretty easy to know the dependencies. So for A, B, and D, apparently we don't have any prior steps, any prior activities. So we could start A, B, and D at the same time as the first step. But for C, apparently A is the prior step. So the time of A should be smaller than C. So this is the way we're going to constructing all the dependencies in here. A smaller than C, and B and D are smaller than E, and B and D smaller than E. We'll list all the dependencies in this table as equation in here. So the meaning of this is that if A is smaller than C, so that means we cannot start to do C before finishing A. So that means if the finishing time of A should be equal or earlier than the starting time of C. So we calculate the finishing time of A in here as the left-hand side, and we calculate the starting time of C as the right-hand side. So how to find out the finishing time of A? So that's pretty easy. So we know the starting time of A, and we know the duration. So we're using starting time plus duration. That's the finishing time of A. So and we have the starting time of C. So apparently, if A is smaller than C, so we're using right-hand side minus left-hand side. So that means that should not be negative. Should be 0 or positive. So apparently, this is a basic logic. So we do this for every constraints in here, for every dependencies in here. So apparently, we don't know, if we don't know all the starting time, all the slacks are in here are negative. This is not allowed. So we hope to make the slack not negative. So it could be 0, could be positive. And at the same time, we hope to basically minimize the whole duration of the whole project. So this is this is the first objective. And if you are trying to use in solver, that's pretty simple. We should be minimize the total duration. That's basically the starting time of the final step. So that's basically the final and finishing time. And we would like to change the starting time. So this is the all and times all numbers we like to change. And at the same time, we would like to make this as the integer. We don't starting at 1.5 day. So this doesn't make any sense. And we would like to make the slack. So this is the time difference between the starting time and the prior activities, finishing time of prior activities. So if we have all the constraints, that should be not difficult to solve using the linear programming. So we can have basically the result. That's basically the task for question number 3. We need to solve using solver and to find out might not be the best way, but it's one of the solutions to maintain the constraint of the dependencies. Okay, and then after that, we're gonna have to consider something more, that is the resources. Okay, and we have one more constraint, so no more than 5 members of staff. That's our constraint for staffs. And in here, so the project cannot take more than 14 days. So this is actually an additional condition. We should be able to identify this if we could draw the Gantt chart. And in here, so if we have the early start and early finish, late start, late finish, so the times in here, so it's quite easy to draw this, and we could identify we have conflict in here. So how to move this according to this, we can finally identify, so we have to basically extend the whole duration if we consider the constraint of the resources. So I basically created one of the, this is the Gantt chart, but this is not requirements again. So, and this is the very initial, I wanna close this. Yes, yeah, this is a very initial schedule based on the early start. Yeah, yes, in here, oops, yeah, in here. Based on early start. Apparently we have several items in here, so that's the resource conflict. So in total, we only have 5, but this is higher than 5, so it's automatically to be red in here. So we would like to move. So apparently we have this. This is a free flow. So, and this is also free flow. So we would like to move. So if you can see, this is the difference. We would like to move and 2 activities, C and F, to slightly different, to have a slightly different conflict. But apparently this doesn't work, so we would like to do further movings. So if we like to move C and to here, starting from day 4, so apparently we can solve this. But we have another conflict. We still got a conflict in here, so we can keep moving, but in here, so it's not possible to solve if we just move this. So basically we move and E and G. So that means we're gonna have, if we like to move G, we're gonna have to move I. So that means we're gonna have to extend the whole duration of the whole project. But this is still not working. So if we keep moving, so if we move the F to 2 days and ahead, so that means we can basically solve everything in here. So this is manually solving, try to using the Gantt chart to take a look on all the resources. Okay. And you don't have to do this again, but that could be very helpful for understanding whole process. Okay, so and then the next step in this question is to consider, what if we only have 5 guys, 5 members, and so the total days should not be more than 14. So we should try to have all the informations in here. So resource. So, resources. And according to here, so that's basically resources in here. And 2, 1, 3, 2. And so I want to have 2, 2, 1, 3, 2, 3, 3, 2, 2, 4. And 3, 3, 2, 2, 4. And last one is 0. Okay, I hope it's correct. So 2, 1, 3, 2. 2, 1, 3, 2, and 3, 3, 2, 4. Okay, so that's the resource informations. We know for every activities we have quite different resources, but we don't know. So for every single day, because we have quite long time, so 13 or even 14 days, we need to identify which day. So at a specific day, how many resources we need. So we to help to find out that we need a little bit, Excel skills in here. I would like to copy all the activities from here to down here. So, and I would like to give some days like 0 and 1. So this is just to identify the days, and maybe to 14. Okay, now it's possible to create a new matrix. So for every activities from day 0 to day 14, so for every single day, so how many resources we need. So if we take a look on A in here, A started from day 0, and duration is just 1 day, and resources 2, we needed 2 staff. So that means we hope we can have 2 in here, and all the other days should be 0. So this is what we like to do. And to achieve this, so apparently we could using some small functions in Excel, and this is if. So we use starting time and finishing time to identify the certain days that we should carry out the certain activity. So that's basically 2 conditions, starting time and finishing time. So we use another function called AND. So this is basically 2 conditions. If the 2 conditions are both true, we identify the certain days that we need resources for the certain activity. Okay, so the starting time, that should be smaller or equal to the left-hand side, the number of days. And the finishing time, that's equals to starting time and plus the duration. That, oops, I forget something. Yeah, starting time plus the duration, that should be higher than the left-hand side. If this is true, so we need stuffs. So how many stuffs? For A, the number of stuffs we need is actually 2. So otherwise, we need 0. Okay, so in here, so that means, okay, in 2, this is 2. So we would like to do this for every day down here. So it might be possible to replicate, but if we do this, apparently it's not working because if you double click, so apparently those cells are going down. So this is not what we like. So we have to fix some of the cells. So this is the basic skills in Excel. We would like to fix 1, 2, 3, 3 cells from the moving at the horizontal directions. So this should be giving a US dollar on the right-hand side to the letter. And okay, let's see here. Okay, so if we have done this, so I could basically replicate the same functionality down here if we check this. So apparently for day 6, we compare the starting time and durations and the finishing time with day 6. Okay, for activity B, apparently we would like to do very similar things. So, but is it possible to replicate from A? Maybe, but if we replicate, so another problem, so the red cell has been moved to the right-hand side. This is not something we like. We have to fix the number of days in here. So that means we couldn't do this. We're going to have to change this a little bit. So we have to fix this. So from the moving at the horizontal direction. So this is, we're putting US dollar on the left-hand side to the letter. So if we're finishing doing this, so I want to replicate this, and then replicate to the right-hand side. If we double-click, so that's basically working fine. And we can select them all and double-click. So basically, this is the replicating for all the cells. I want to have a check. For example, for activity E, that should be starting from day 6 and duration 2. So we need 3 stuffs. Okay, starting from day 6 and duration 2, so that means just 2 days. And for H, starting from day 8, duration 3, we needed 2 stuff. So that's starting from day 8, duration is 3, we need 2 stuff. Okay, that's actually how we using some skills in Excel to calculating all the resources for every activities across every single day. Okay, now we could calculate the total and find out available and overshot. So total, that's pretty simple. That's just the sum of all the stuffs, number of stuffs in the Excel for every single day, and we could replicate. Available, always be 5. So, and overshoot, that's pretty simple. That should be the total number we need and minus the availability. So apparently, if we do this, we got some negative things. So negative means, okay, so basically we need 3, we actually have 5. This is less than all we need. Okay, so in this problem. In this question, what we like to do is minimizing the overshot. So we don't like this. So this is 1, we don't like this. 1 means that we need more than the availability. So we would like to do a total and overshot. But we got a problem if we do find out the total overshot. So we got a number of negative. So the reason of that is we don't care. We actually have some negative overshotting here. So this is actually not good if we like to minimize the overshot, because this is a negative. If you like to minimize something could be negative, that really doesn't work, because we could have very, very huge number, absolutely numbers of negative numbers. So what we like to do is, because we don't really care about the negative things, because negative means, okay, we don't need so many stops. So if this is negative, we just ignore that. So that could be just 0. What we would like to do is we change this to another function. I would like to compare the overshot and 0. If this is negative, that's fine. We just take 0. Okay, so I change this. Okay, fine. So I compare the overshot and 0. If this is negative, just give it 0. So by doing this, so all the other items are just 0. We have highlighted those 3 days with overshot. Okay, now we got overshot 3. So that's good for us. So what we like to do is now we need to minimize overshot and to maintaining all the other conditions. So let's take a look. So how are we going to do this? So apparently we need to minimize the overshot and minimize and trying to change this. Yes? And I would like to make this as an integer, and this a whole number, and also this is higher than 0. And at the same time, what we like to do is I would like to add slightly more condition, because we know from the analysis, and also in this question, this is a given condition. So in here, the project cannot be more than 14 days, but this could be analyzed from the Gantt chart. So could be analyzed from the manually analysis of the time and the resources. Okay, we would like to add this as one of the condition. Also, I would like to add another condition as the boundary. So that means our starting time should be higher or equal to the early start. So early start is the possible earliest time we could start every activities. So it's not possible to start later than the early start time. So because this is the constraint. So we add this. Okay. So now if we choose linear programming, no, it's not working. So because this is not a linear problem. So this is a pretty non-linear problem. So what we would like to do is to choose evolutionary. So, but this is the tricky things. So it might not be possible to immediately get your results. If you click on this, maybe it takes 1 or 2 or 3 or maybe more than 5 minutes to finish all the optimization. But maybe sometimes it's not working, because an evolutionary algorithm does not guarantee convergence. So that means you could have a try. Let's have a try. See. So are we lucky or not? We don't know. It takes some time. So we give it more time. And then we're going to moving down to here. Take a look on the next question. So the next question is about crashing. Crashing is an easy to understand. So what if we like to pay more to buy more resources so we could save time? So now we have several conditions. So we have B, C, D, G. 4 activities. We could pay more and we could save some time. So what if you like to make the whole duration of the project as shorter as possible? It's possible, yes. We could pay more. And we have the money and the time, so we can save. Oops, we got some result in here. Let's take a look, see how it looks like. It's not good, just 1. I want to keep this doing again. Okay, try to make this work. Okay, so we take a look. For example, for B, we could spend a lot of more money, and so the previous cost is just 60,000. Now we can spend 90, and so basically we could reduce the time to 3 weeks. So previously it was 6 weeks. So that means okay, we can save some time. So we could basically calculate one thing called a crashing factor, crashing rate for every activities, and we take a look on how we could solve this. But a slightly difference of this question, if compared with examples in the lecture. Let's going back to here and take a look. Still 1, it's not good. So what I like to do is I wanna remove all of this and let the algorithm try to do this again, but I'm not guaranteed it's working. Okay, so let's go. Going back. So we don't have actually, for this question, we don't have a budget. So we would like to know, so which activities is worth crashing, and so continue, still 1, and let's try to keep working. And we would like to have a total cost of a crashing if we select a certain activity to be crashed. So we don't have basically a budget. So we cannot try to minimize the total budget, so make the budget as within the limits. It's not possible. So that means for this, what we could do is we could try to make the duration of the whole project as shorter as possible by using those resources. And finally, let's take a look and what is the total cost if we consider all the possible conditions in here. So this is slightly different from the examples we have in the lecture. Let's take a look. This time we are lucky, we got 0. So when you are trying to do this, so my suggestion is probably to remove all of those starting time to be 0 and to make it work. And so maybe the first time the algorithm does not converge to 0 in here. So that really doesn't matter. So we click on that solver again to let the Excel try to work on the same problem again. So because evolutionary algorithm is like how the different animals evolves across the billions of years. So that's could be having different results. Because optimization for a complicated problem does not guarantee a global minimal. So that could be local minimal. So that's the problem of optimization. Okay, so that's basically another topic. And we're going back to here. So we'd like to know what is the total cost of a crashing if we try to make the very short time period. So when we consider this, one thing I like to highlight is when we consider crashing, basically we only consider the basic conditions, not including the resources. So we're not considering everything together. So that basically make everything. Too complicated. So we don't like to involve everything together. So when we consider this, so that's basically based on very initial conditions. We are not considering the resources. So we just consider, okay, so what if we could buy certain things, and so we don't consider the staffs and constraints of 5 memberships. So we don't consider them together. So, okay. Yeah, what I like to do is I like to remove some of the things from here, and that's the resource. Yeah, we don't actually need this. And so what I like to remove is all of those. Yes. Okay, and yeah, I don't need this. And okay, that's almost everything. Okay, yeah. So if we like to consider this, we have to think about how we're going to calculate the crashing rate for every possible activities. And here we have B, C, D, and G. So crash rate, yeah. And so there's new durations, and also we have a crash limit. So the duration. Okay, so the new durations is the basic information we have. So for B, the new duration is 3. So I want to write it down to here. It's 3. And for C is 2. And for D, it's actually 2 again. And for G, it's actually 1. Yes, it's 1. Okay, and then if we have the new durations, so this is basically the shortest duration we could finish different activities. So we could basically know how to calculate the limit. So that's how many days we can save, the maximal days we can save. That's the old duration minus the new duration. And we can basically having this, yes. Okay, so, and then we can try to calculate the crash rate. So crash rate is basically the cost difference divided by the crash limit. So for the B, we could, that's the 90 minus 60 divided by 3. Okay, so that's the crash rate. And for the next one is the 16 minus 10 divided by the crash limit. Yes. Okay, and so the next one is the 25 and 20, so equals to 25 minus 20 divided by the crash limit. And the last one is equals to, where it is? 16 and minus 8, so it's 16 minus 8 divided by the limit. Okay, so that's the crash rate. And now we need to determine, so how many days we like to save? We don't know, crash and factor. So this is basically the B, C, D, G. Okay, so this is actually, and how many days we like to save. So far we don't know, so maybe we could give it like a 0, 0, 0, 0, something like that. And so something we like to know is the crash and like a cost. Yes. So crash cost is basically based on, so how many days we like to crash times and the crash rate and plus the how many times we like to and times the crash rate plus the crash rate plus times the crash rate. Okay, so that's actually the crash cost. Okay, think about the question. So now we have, we need to determine the crash rate. So how many days we like to save. So that means how many days we like to make the whole duration shorter. So we will consider this as a whole. So, and we will basically like to minimize the total duration. And now maybe we could change some of the duration of B, C, or D, or G. So, and what if we got some numbers in here? For example, 1, 1, 1, 1. Okay, we got some cost. But what if we have 1 on B? So that means we like to save 1 day for activity B. What if we save 1 day for activity B? So what is the result? So that basically means the duration of B is not 6. So 6 is the very initial duration. So now we like to pay more. So that means we can save 1 day. Finally, the total duration of B should be 6 minus 1. That should be 5. That's the new duration. So that should be something we have to calculate it. We have to consider in this all calculations in here. If you're looking at here, so this is actually, left-hand side is the finishing time of B. So because we have the dependencies in here. So B and the finishing time of B is the starting time plus the duration. And now what if we can save 1 day? That means the finishing time should be 1 day before. So that's basically the new finishing time of B. And if we have some, basically save some days for C, so we could calculate the C's in here, so minus the days we like to save. And similarly for D, we can minus the days we like to save. And for G, where's G? Yeah, G is in here. So we like to using this minus, so this is how many days we like to save. Okay, and now we got some new slack in here and some new days in here. Okay, so let's think about how we could minimizing the whole duration. So let's take a look on solver. So what is our target? Our target is due here, starting time of the last activity. So this is the whole duration. We like to minimize that. And to change, actually this time, we would like to change something more because we would like to consider how many days we like to save. And then, so this is smaller than 14. We don't need this. This is for the resources. And integer, so this is also for the resources. And okay, so this is integer. So that's okay because we would like to consider this as integer. And this is a slack. This is also okay. So we would like to make the slack not negative. And we would like to add slightly more than that because this is actually crashing factor. We cannot save in whatever days we like. So the crashing factor should be, the 3 crashing factor, that should be smaller or equal to the crashing limit. So this is the maximal days we can save because this is based on the older duration and the new duration. So in total, we can save 3 days for B, 2 days for C, and 1 day for D. Okay, and oops, I got something wrong in here. So yeah, this is the crashing factor. That should be smaller or equal to the crash limit in here. Okay, this is one limitation. And another one is the last one. That should be smaller or equal to the crash limit of G. So, okay, and anything else? That's probably everything. Hopefully I'm correct. So in this example, we need to use linear programming. So we don't actually need the evolutionary. Okay, let's take a look. Looks like everything's correct. So we got a new result. So yes, let's check this. So we would like to save 3 days for B, 1 day for C, 0 for D, 2 days for G. So now take a look on this. So this is quite different. So this is the starting time of the last activity. So that means the total duration is 8 days. So we save a lot. But we got this. That's our crashing cost. And we check on the slack, all correct. This is not negative. And we check in the limit. So this is 3102, 3212. So okay, so this is satisfying all the constraint. Cool. So yeah, basically this is the last question. We could find out what is the total crash, what is the total cost of the crashing, and we know how many days we like to save. Now, basically, the duration of B, C, D, and G has been changed, so it's not the initial durations. Okay, so that's quite brief introduction, but I believe it's a quite good discussion in detail of all the things. Okay, so that means what? That means you may follow the video, today's video, in tomorrow. And tomorrow, we are not going to have any discussions on the questions. And this is rule number 1. Rule number 2 is those type of questions will not be answered. Because in the last 2 lab sessions, I've been asked a lot of questions. Oh, I don't know how to do this. Can you fix this to me? And now, so don't ask me. I got the same result. I got a very similar spreadsheet. Why is it not working? And can you fix this for me? No, it's not working. So this is the last lab session. You should be able to fix everything for yourself. And we have a quite detailed videos in here. Watch the video and fix everything for yourself tomorrow. Yeah, please. It's automatically uploaded by the whole system, not by me. Yeah, by the university. I think it should be within 1 hour after the lecture. Yeah. Did you check for every time, so after the lecture, so the lecture video will be automatically uploaded on the system? You could check that. Check on it. Yeah, please.
For me, the upper replay system, default settings are that the lectures recordings are uploaded 24 hours after the recording.
They say 24 hours, but for most of the time, that within 24 hours.
Okay.
So,
Is it okay to email you if it's not uploaded?
but I couldn't do anything on that. So this is a central IT system. So everything is automatic. I cannot stop recording this. I cannot helping, uploading this. I couldn't do anything. But this should be ready there. And anyway, you have basically listened to everything in the lecture. You should be understand. And also, we have quite similar examples in the lecture. Okay, so good luck for your lab sessions. Yes?
So all we need to go through before the lab is the lectures from week 7, right?
Only the lectures of a project management. Yes.